Good day. Today we are looking at question 8 of the November 2013 paper, and it's about electrostatics. Okay, in the diagram below, point charge A has a charge of plus 16 microcoulomb. X is a point 12 centimeters from point charge A. So I've got my charge here of plus 16, the distance, and we are looking at point X. So first of all, we need to draw the electric field pattern produced by point charge A. Now, if we draw this charge, we must remember it's from positive to negative. And you must try and have your lines almost perpendicular on your point charge that you draw. And your lines need to touch the point charge. There. Alright, that will give you the 2 marks. Is the electric field in question 8.1 uniform or non-uniform? Uniform will mean that the strength is the same everywhere. Or non-uniform, the strength differs. We know that the closer we get to a point charge, the stronger the field is, and the further away the weaker. So it will be non-uniform. Right. Now 8.3, calculate the magnitude and the direction of the electric field at point X due to point charge A. So we have charge, distance, and we are looking for electric field. So if we look at our information sheet, E is your symbol for electric field strength, but we have charge and the distance. So that is the formula we'll be using. So just the normal E is KQ over R squared. K is given on your information sheet as 9 times 10 to the power of 9. It's that constant. Q is 16, but microcoulomb we need to change it into coulomb, minus 6, and the distance is 12 centimeters, and if we change that into meters, we divide by 100, 0.12 square. That will give us 1 times 10 to the power of 7 Newton per coulomb. Good. Next question. Another point charge B is now placed at a distance of 35 centimeters from A. As shown below, the net electric field. Now this is very important to us. The net electric field at point X, due to the charges A and B, is 1 times 10 to the power of 7 newtons per coulomb west. So when you see that, you must remind yourself about the formula. E net is E of A plus the E of B. And what they give us is this value, 1 times 10 to the power of 7. But they also give us west. So if we look at our previous answer, this one is to the east. Right? And we have it as positive. So we take east as positive and west as negative. So this value that we are going to substitute in there has to be negative. Right. And then we already have this value. Let's see what they ask us. First of all, they want to know, is this point charge B positive or negative? Now we need to, again, just look at the direction of our fields. A we know is positive. It works outward. Now E net, the field of A plus the field of B, will give me a net field to the left or to east. So for this net field to be to the west, it means that B has to also push X to the west. So we will have a field in the negative direction, and it must be greater than that of A. And for the field to go outward from B, it needs to be positive. So our answer is positive. Then the next question asks us to calculate the magnitude of the point charge B. So now we are looking at Q. And if we look at the information we have net force. Then we already calculated the force of the field of A. And we need to get this B field before we can get the charge. So we will be starting with this one. Calculate the electric field of B and then calculate Q. Right. So we will start with E net is EA plus EB. E net is minus 1 times 10 to the power of 7. A is positive 1 times 10 to the power of 7 plus the electric field of B is what we will be calculating. And we will get an answer of minus 2 times 10 to the power of positive 7 Newton per coulomb. Right. And if we have that, we can go and calculate using the same formula there, but now for B over R square. We already have the electric field strength. You don't have to put in the negative, that's just direction. We do have K. Q is the question that we are looking for. And now the distance. Let's just go back to our diagram. And if we look at the distance, it's from X to B. So from A to B is 35, and from A to X is 12. And if you subtract these two, we will get the distance from X to B, which is 23 centimeters. Right, so that is what we will be substituting in here, just in meter form, 0.23 squared. And that will give us a value of 1.18 times 10 to the power of minus 4 coulomb. Right.